Start off with elasticity. As a reminder, elasticity is the responsiveness or sensitivity of demand to a change in price. We have two terms that we focus on. One is inelastic and the other is elastic. We talked about several kinds of elasticity in this unit. We talked about first elasticity of demand, defined as percent change in Q of A demanded when there is a change in the price of B. So products A and B, the price of Coke goes up and the demand for Pepsi goes up. Cross price elasticity of demand for these products is positive. That means that Coke and Pepsi are substitute products. If on the other hand, the price of product A goes up and the demand for product B goes down, we get negative cross price elasticity. So gas and SUVs are complements. Remember, the signs matter when we're talking about cross price elasticity of demand. We talked about the income elasticity of demand, defined as percent change in quantity demanded over percent change in income. We also talked about normal goods and inferior goods. What happens? Normal goods, both income elastic and income inelastic goods. Income goes up, and let's look at the differences in what happens. If income goes up 5% and demand goes up 10%, the income elasticity of demand in this case is 2, and it's positive, so it's a normal good. There we go, normal good. Income goes up 5% and demand for vegetables goes up 1%, so the income elasticity of demand for this is 0.2. It's also positive, so it's a normal good. But look at the difference here. Greater than 1, less than 1. So you have an income elastic good, income inelastic defined by that plus 1, or rather greater than 1 and less than 1 elasticities. Inferior goods, negative elasticity, income goes down, and the demand for an inferior good like Spam goes up, gives us a negative elasticity, so it's an inferior good. And again, in this case, the signs do matter. We talked about price elasticity of supply, defined as percent change in quantity supplied over percent change in price. This measures the change in supply in response to a change in price. So it measures changes in the supply curve rather than changes in the demand curve. We talked about availability of inputs and time and how they affect price elasticity of supply. We talked about 3 different goods and whether you can get more inputs quickly as demand for these goods changes. And the definition here quickly, or rather the explanation, if producers can get more inputs quickly, the elasticity of supply will be higher because they will increase supply to respond to increased prices. If they can't get inputs quickly, like in the case of a satellite, the elasticity of supply will be relatively lower. We talked about price elasticity of demand. Here you can see the definition. Here you can see further detail. And then we had an example. I'm glossing over this because this one's pretty straightforward. I don't think we had much of discussion or rather issues on this. So pause and read this if you have questions. All right, let's move on to consumer and producer surplus. What are we talking about here? We're talking about willingness to pay. Willingness to pay is the maximum price at which someone will buy a good. Here we had the stair-step effect because we had a very small number of consumers and we had here the prices they were willing to pay. Individual consumer surplus was defined as the difference between what somebody would have been willing to pay and what they had to pay. Consumer surplus here, here, and here, if this is the price. Total consumer surplus is the sum of all of those individual surpluses. If the price changes, price in this case goes down from this price to this price, not only do we get an increase in consumer surplus, we also get additional buyers into the market. I think this says Darren. So turn this into a straight line demand curve and you see consumer surplus defined as the area below the demand curve and above the price. If you have a change in price, and in this case you have an original price that was $5,000 and a decrease in price to $1,500, what happens? You have your original surplus here. When there is a decrease in price, you get not only increase in consumer surplus from those original buyers, you also get a new consumer surplus gained by the buyers that were not in the market who are now in the market. Let's flip over to suppliers and the supply curve. Here you have, similarly, you have stair steps. You have here the amount that each was willing to accept for a good that he or she was selling. So think of it as cost versus willingness to pay. Here you have producer surplus, the difference between what I would have accepted for a price and what I was able to get. Here's one individual producer surplus, 2 and 3. If there were a price change in this case, price went up, you'd not only have additional producer surplus, you'd also have a new supplier in the marketplace. Here's total producer surplus defined as the area above the supply curve and below the demand curve. Here, if there's an increase in price, you see here from $5 to $7, you get not only additional surplus from those producers who are down here, who are now getting more for their product, you also get new producers into the market, defined as this area, because they weren't willing to sell at this price. But at this price, you get an additional 500,000 bushels of wheat. And for the sake of the discussion here, you assume that you are actually getting more sellers into the market. Here then, if you add those together, you get consumer surplus and producer surplus. If you're asked on a test for the total surplus is the area of this triangle divided into two pieces, then consumer surplus and producer surplus. Here are some items for you to remember and to memorize. Pause here if you need just time to remember all this stuff. Okay, let's talk about tax incidence and what happens. Well, in the case of a tax paid by a supplier, remembering factors that can shift a supply curve, the supply curve will shift upward. And in this case, the supply curve shifts upward by the amount of the tax. So you can see that there's a $40 tax that's been imposed per room. That means that the level of the tax is actually going to go up. Rather, the supply curve will go up by $40. What happens? $40 excise tax inserts a wedge equal to $40. That wedge starts here effectively, pushes out until you have a $40 gap between the demand curve and what was the supply curve down here. That defines how far it goes up. You find your new price, and you can also define missed opportunities, defined as those people who were in the market who have now left the market because of a change in the price of a hotel room. Conversely, if you have an excise tax and it's imposed on the consumer, so the consumer has to pay for it, you see a downward shift in the demand curve. Again, you see a downward shift in the demand curve equal to the amount of the excise tax. Wedge pushes over. You now see the distance represented by that tax. You see the resulting, because the demand curve went down, you see the resulting price, which is $60, and you see quantity going down from 10,000 to 5,000. Now, very important to understand here, if the excise tax is imposed on the consumer, they are also paying this amount, which is the tax. The price that the producer would charge is here, but the price that the consumer pays is the price charged by the producer plus the amount of the tax. Here you see really quickly in those two examples, the impact, the net impact, net effect of the tax was the same, even though different curves are shifted. Let's move on to more of a realistic depiction of price elasticities and tax incidence, because in the real world, tax incidence doesn't impact consumers and producers equally. There are different elasticities of demand and of supply. In this case, when the price of gasoline goes up, you have low price elasticity of demand and you have very high price elasticity of supply. In this case, because the price elasticity of demand is low, meaning I don't have much choice. I'm going to buy it almost relatively independent of the price. The tax burden is falling mainly on consumers if there's a $1 per gallon tax put in place. Conversely, in the case where the price elasticity of demand is very high, so I as a consumer will likely leave the market if there's a significant price change. And on the other hand, suppliers face a low price elasticity. The burden of the tax falls mainly on producers because they don't have as much flexibility or ability to leave the market as I do as a consumer. Here, just a quick reminder, area, if somebody asks you benefits and costs of taxation and how much revenue is generated, here it is, right here. It's the amount of the tax times the quantity that's being taxed. Here's our four-part. You remember here from today in class and from last week, we have upon implementation of a tax and a movement leftward to the new market price, you have a loss of consumers and a loss of producers who were participating in the market, otherwise known as a deadweight loss. You also have a decline in consumer surplus and a decline in producer surplus. Remember, you don't lose all of the consumer surplus. That's the white area. And you don't lose all of the producer surplus. That's the white area down here. Let's talk quickly about utility. Utility measure of personal satisfaction. You'll hear us talking about utils. Marginal utility is the change in total utility from consuming one additional unit. Diminishing utility says that each additional unit consumed results in a smaller addition to total utility. Remember the idea of increasing at a decreasing rate, and that's actually depicted on this graph. Here's a utility function charting total utility against quantity consumed. And you see how quantity consumed, as it goes up, total utility continues to increase, but at a decreasing rate. This then is marginal utility against quantity. And the difference here is marginal versus total. So as you can see here, marginal utility decreases as the number of units consumed increases. We've now looked at this one several times. This is the budget. This is the budget line. This is different combinations of consumption of the two products that are graphed against the two axes. We have here the actual data that was put into this chart. We also have here the total utility derived from the different combinations of consumption. What does that tell us? Well, total utility helps give us an idea of utility maximizing amounts. Keep in mind, we're still looking at the budget line. We're looking at consumption bundles. And we're also very cognizant and aware of the fact that we have quantity of one product moving one way and quantity of the other product moving the other way. That allows us to create this graph. Now, when we talk about how much we should spend on each good as we work to optimize our consumption, we need to consider cost. Introducing cost takes us from the idea of marginal utility to marginal utility per dollar, calculated by taking marginal utility and dividing it by the cost of that additional input, and in this case, an additional pound of clams or an additional pound of potatoes. Where do we want to spend? Well, we want to spend where the marginal utilities are the same, and specifically here, where marginal utility of dollar spent, so defined as marginal utility of a good over the price of the good, where those two are the same. Lastly, what does that give us? It gives us curves representative of marginal utility per dollars. Again, quantity of one product goes this way, quantity of the other product goes this way, marginal utility per dollars on the y-axis, and the optimal consumption point or optimal consumption bundle being the point at which the marginal utility per dollar spent on clams is equal to the marginal utility per dollar spent on potatoes in this case.